set, and then based on the chart, so what you can see, visualize your data set. Okay, so you say that I can see trend is increasing. Okay, so there's a trend variation. So whether you see cyclical, no. So whether there is seasonals, maybe 1 year, maybe month. Okay, so then you need to plot your SCF chart. So check whether there is seasonal variation. Okay, so then you test the stationary. Okay, test stationary. So you can use what hypothesis testing. Then when you see the trend increasing, if you try to decompose your time series, then you have trend increasing. Then you say that non-stationary. Okay, explain why non-stationary. Then after that, this is the hypothesis testing that you can use to check stationary or not stationary. Okay, so then a lot of methods. So you want to make after you test your series not stationary. So as long as you have trend increasing, mean not constant, or decreasing not constant, or you see that your fluctuation, the variance different. Okay, then variance not constant, also not stationary. So then the next step is to eliminate your non-stationary, so the trend and seasonality. Yeah. So we say make your series become stationary. So then after you decided you transform when you have multiplicity variation, or you do trend differencing 1 time or 2 times. If you have seasonal, you do seasonal differencing. Okay, 1 time, then trend differencing 1 time. Then test. So this is decompose. Okay, after decompose, we say that is non-stationary. So moving average, order 5 order, check seasonal order. Alright, so then order 1, order 2, order 3. Then let's say you want to fit using ARIMA. Okay, so of course you have auto ARIMA. Then by performing differencing tests, so you have the ADF, okay, a lot. Okay, so how many times and differencing? Okay, what's the PEQ? So you have seasonal, then you have trend differencing in front, then seasonal differencing on the back. So check how many times you want to do differencing, so that your model becomes stationary. Then you see in the ARIMA model, there's a D. Okay, so here, okay, so whether you have differencing or not. Then you check your residuals. So you have your residuals. Standardize your residual, the normal plot. Or here you are using SCF plot, polylogram. So your polylogram, so your dots here not deviate from 0, except for 0 left. Others not different from 0 or within the 95% interval. Then your model well fit. Okay, your model well fit. So if cut off, then you need to fit others model. It might be whole meters, or average moving or smoothing, or you want to use regression, the curve fitting, right? So then choose one which is good fit. This one using after, let's say just now we say good fit ARIMA for stock price, then you will come to recommend ARIMA with the model used for forecast. Okay, then you show your forecast value. Compare with your test set. Okay, so this is the test set that you speak. Okay, so this is the ARIMA model that you predict by the ARIMA model that you propose. Okay. Then model diagnosis evaluate the performance. So then you have your test set and test set RMSE, so you can compare. So whether they are underfitting or overfitting. Okay. Forecast error. Okay, compare the forecast error. Then you need to write your model and then your conclusions. So what are the model you suggest to predict the price? And then among what model you have tried, so which model will fit, okay? And then what's the accuracy, okay, of your forecast? Then the model. Okay, and then the model. So like the report. Like the report here. So you should have your plot. So this is the first thing. Then you do some testing, okay, stationary testing, whether your time series is stationary or not. Then you remove your non-stationary, then check again whether it becomes stationary or not. Then how many times different thing it becomes stationary. So then the model that you fit, then you do checking the residuals. Stationary. After different thing, whether stationary lah. This one checking. So you fit ETS, ARIMA, linear model. Okay. So then you compare the RMSE, compare the residual plot. Okay. So ARIMA, it finds that ARIMA residual is within 95% intervals. Okay. So then the ETA also here, the residual within 95 intervals. Okay. So then it takes the 20 set testing set RMSE of these two well-fit model compare. So model diagnosis, and it suggests ARIMA, this model for forecast. So then you need forecast model. So from this ARIMA, so you write out your equation. So then from your output, you substitute the coefficient. So this is the model. Then you must do a forecast comparison with your test set. So what's the value of your forecast error? Then you write in your conclusion. Okay. Then that, okay. Reference, additional information. Then your coding. So coding at the back. So this content is 12 pages. Coding. just check write your own coding. So combine your processor from process 1 to until diagnosis, check, and focus. Okay? Come on. Okay, so this one is the chart that some attach, some did not attach in the content. A bigger one. Okay, so the chart you attach, so you explain. This is no difference. One order one. You say seasonal difference. One time, then order FA1. 1. Multiplicity. Okay, not good. So it says here touch. So that they use AAA. So your SF without touch. Okay, so some additional output if you did not attach in the content, but you mention it, then you might want to attach